here's the video for my problem number 5. Corresponds to exercise 853 in the textbook. This is the Journal of Accounting Research problem, and it basically goes down to calculating two confidence intervals. The first confidence interval, it's going to be a 95% confidence interval. That is, the confidence level is 95%. We're given a t-value, and we're given degrees of freedom. We're also given means and standard deviations up above. So as we recall, let's go ahead and put the data in here. If I can type. So we're given a mean, which is x bar. Again, that's the sample mean. We're given the standard deviation from the sample. We're given the sample size. And then we are given the t-distribution value, or the t-multiplier. So this, we can get an upper confidence limit and a lower confidence limit based on all that information. Okay, so let's read through here. Mean audit delay. So let's go through here. Study random sample of 250 yields mean audit delay. So 250 is our sample size. The mean is 68.04. Standard deviation of 35.72. The t-multiplier we're given is 1.97. Notice this is t sub 0.025. That 0.025 is exactly alpha over 2, where alpha in this case is 5%. 100% minus 95% is going to give you the alpha. In other words, the confidence level gives us the proportion of the times that we're going to be correct with our estimate, and the alpha is going to give us the proportion of times that we're going to be wrong with our estimate. So the upper confidence limit is just going to equal x bar plus that t-multiplier times the standard deviation divided by the square root of the sample size. And the lower confidence limit is just going to be the same except minus x bar minus that t-multiplier times the standard deviation divided by the square root of the sample size. So the lower limit always goes to the left. We need to round to 3 decimal places. 5, 8, 9, 5. So that rounds that 9 up to 0. So 63.590. And then the upper is 72.490. That's less than 5, so it's 0.490. Excellent. Now the second set. Mean audit delay for all financial companies. So we got 238 financial companies. Mean audit delay of 56.74. Standard deviation of 34.87. And again, we're given the t-value. Again, it's 95%, so alpha is 5%. Which means alpha over 2 is 2.5%. Again, it's going to be the mean. The upper is going to be the mean plus that distributional multiplier times s, the standard deviation, divided by the square root of n. And the lower is going to be x bar minus the multiplier times the standard deviation divided by the square root of n. If you have trouble with rounding to 3 decimal places, let's go ahead and open this up a bit more. You see these two? This one increases the number of decimal places, this one decreases. So if you don't want to do the rounding in your head, you can always use that function in Excel. 287, 61.193. There we go. And then C, by comparing the 95% confidence intervals that we calculated up above, notice that this entire confidence interval the one corresponding to the mean odd delay for financial companies, is less than this entire confidence interval, which is the mean odd delay for industrial companies. So we can confidently say that financial companies have a lower mean odd delay than do industrial companies. So by comparing the confidence intervals, is there strong evidence? Yes, there is. The financial company is shorter than the mean. This is shorter than this, because the highest for the financial is lower than the lowest for the industrial. And that's it. That's how you calculate confidence intervals using Excel. Notice what information is given to you. You're given the sample mean, the sample standard deviation, and the sample size. This t-multiplier is not always given to you. How would we calculate it? Well, here's how you would calculate it. It's t.inv, and since we're working with a confidence interval, we could do a two-tailed, that's what 2t stands for, and doing .2t actually divides the alpha by 2. You have to give it two pieces of information, the probability, which is the alpha, 0.05 in this case, and the degrees of freedom, which is n minus 1, comma, n minus 1 here is 249. So that's the actual t-multiplier. This is one given to us by the book. If we want to look at the t-multiplier for the second example for the financial companies, notice that the sample size is different. So instead of 250 minus 1, it's 238 minus 1. And we get this for our t-multiplier, for the more precise t-multiplier. But the rule is if Connect gives you the numbers, use those numbers. Connect gave you 1.97, so you would use 1.97. But if you want to do these calculations yourself, this is how you would do it. Notice that I did the 0.2t. The effect of doing that is exactly the same as 0.05 divided by 2. That 0.05 comes from the 100% minus 95% to divide by 2. And again, 237 for the sample size. And you're asking, why is one negative, one positive? That really doesn't matter much, because this is, the upper will be the larger of x bar plus that multiplier times s over square root of n, and x bar minus the multiplier times the square root of s over n. Times s over the square root of n. So positive, negative doesn't matter, because you're going to have the upper limit being the larger of those two values and the lower being the lower of the two. The purpose of showing you this was the difference between the t.inv, where you have to divide by 2, and t.inv.2t, where you don't divide by 2, where that dividing by 2 is already taken care of. So this was problem 53 from the textbook. Shows how to do confidence intervals using Excel and the long way. Hopefully this was helpful. Have a great day.